Hello. So I'm here with Amit Gupta, who is the founder and CEO of Acubed.IT, and which is a company which creates innovative and secure cross-security domain solutions for customers, such as for the UK government. One of the key innovations is the cross-domain hybrid application CDHA framework, and which aims to break down the barriers in sharing trusted information across multiple agencies. Hi, Amit.
Hi, sir. How are you doing?
Very good. So if you could tell us what your current role is and what does a typical day involve for you?
So my designation in the company is CEO, but my role involves mostly I spend time on doing the architecture or the technical delivery manager role in the company, where I do a lot of stakeholder management and work with the technical teams to discuss the architecture, the problems they may be working on. And in fact, sometimes I go into more of a strategies with the marketing team. So because it's a startup, niche startup company, so I work around more or less multiple roles in the company. So more, a lot of time, I in fact host the Scrum meeting in the morning and sprint retrospective sometimes, and then architecture workshops with senior stakeholders. And sometimes I'm sitting in the some secure places discussing the strategies and architecture with very senior stakeholders.
That's great. And you've had many roles in the past and highly experienced in many different ways. What is it that's led you to where you are now?
Okay, so I think I need to rewind the journey. So I've been in the industry for almost over 25 years now, working as a deep, hardcore developers in the to start with. In 2010, I had opportunity to work with the some of the national security space projects, which was with the defense in Salisbury space and few in the Aldermaston and other areas. And but that was just working and solving some of the key problems they had. But I was just getting the gist of how UK government work and the defense works. How the whole journey changed when 2016 I started working with Cabinet Office and NCSC to build a program which required tier 2 collaborations across UK government. And that tier 2 collaboration, multi-tenant tier 2 collaboration across government led us that there is a massive opportunity and a gap in the industry to exploit and make the best use of that environment is created, that collaboration environment is created. And I think that's the reason where we are today, where we are.
That's great. Yeah, I completely agree. And data sharing is a problem that hasn't been solved yet. And I know that you're interested in cryptography. Where does that passion for cryptography come from?
So I think this cryptography, the journey of cryptography started, in fact, when I started working with the national security space, because every single time we were continuously working on or looking at threats, that threats from the hostile state actors, sometimes threats from the internal insider threats. And I think the cryptography, once you start going deeper into the crypt solutions and solving the data using the crypt, you probably can't stop. And now we're looking at with in fact Napier University to do more advanced crypt solutions to solve some of the other fundamental problems.
That's great. And so what do you think the main challenges are that are associated with traditional data sharing across multiple agencies?
So I think we probably need to, in order to solve this or in order to answer this question, so I probably will go a little bit deeper into the context. Uh, and I think the context setting is quite important for answering this question. Uh, just over a decade, UK government decided, or government security group decided to retire confidential classification. So they used to be classification: official, confidential, secret, and top secret classifications. And confidential classification retired means it created a gap of official, secret, and TS. And most central government had official and TS. And that's where the opportunity came for me working with NCS in Cabinet Office around 2016 to create an environment for data collaborations on a tier 2 environments. During this phase, ROSA is a successful project, and it allows government to do collaborations on the right classifications, but that's only solving the problem of more of a structured data or the video conferencing. It's not yet so, or not. I'm really sorry. I said structured data. I meant to say non-structured data, which is your documents and your chat and your video conferences and email. But yet there is no simple solution for solving the data sharing of structured data. And we collect large amount of data. And what normally happens is we most times work at risk, where even the data is hosted on the silo higher classification data or systems, you end up sharing it in an about way, at risk, at official. And sometime there are paper copies around, moving around, so which actually just creates a threat. So the threat is right now, there's no simple answer of sharing cryptography based data across on the right classification.
And what are the data security risks that you see when data is aggregated in a low trust domain?
I think so. There are two kind of things I normally say to the people, most people. One, the data risk of, so it allows you to create the complete picture sometime. So unfortunately, because the space we work on, I don't want to use the examples of those projects, but single information doesn't give you the complete information. But when you once you start adding the jigsaw puzzles component, suddenly you have a whole picture, and that whole picture allows you to draw that complete picture. So that's one part of the jigsaw. And the second part is the aggregation of records. So let's take example of if it's a sensitive information about one important person is shared, it's a risk, correct? But if that information is shared for the 100 plus or thousands or tens of thousands of people, that's sensitive information, it creates a bigger risk. If you have one CNI or critical national infrastructure, you manage to have or leak a single record of one single critical national infrastructure. That's a risk, but it's still manageable risk. But if you have lost the aggregated data of the critical national infrastructure risks, then the risk is quite big. So I think aggregation in most cases, which can cause a serious damage to the country.
And in your opinion, do hostile state actors and organized criminals have the capability to access data in low trust domains?
So in the space we work in, sir, our working assumption in this national security space or the defense space, our working assumption is if internal users can access data or decrypt data on the low trust domain, and I receive lots of sometime disagreement or people not agreeing on it, but my working assumptions or our working assumptions a lot of time is if internal case workers can access it on the low trust domain, then hostile state actors can access it as well.
And I suppose that's the insider threats. Someone can get beyond the firewall, and then once they're in the organization and they have some sort of trust level, even if it's a low trust, then they can use that to be able to get the sensitive data.
And you're right. And I think even sometimes this could be as simple as phishing attack, and you part of the A organizations, and you will not even realize you're exposing the whole of the network to
Yeah.
some of the hostile state actors.
And has that changed since COVID? I mean, many people are now working remotely. Do you think the move away from physical towards virtual? I mean, some people might be sitting in their bedrooms in their pajamas, accessing sensitive documents. Do you think that's been a change? And is it still still a problem?
So I think the risk, in my viewpoint, and I think it's people have a lot of different viewpoints. In my viewpoint, I think the risk definitely have increased because people are now more working remotely into the organization, and sometime correctly or incorrectly, you will even see people working. And you took the example of a working from home. Some people work problem now working in Costa or Starbucks, joining the open Wi-Fi, which which opens up so much opportunities for if people need to access the information further. So I personally think COVID has increased the risk posture. I personally think.
And and what do you perceive to be the impact of these types of data breaches?
So I think we recently were in the news where our defense secretary was in the parliament as well, and that was, if you think about it, that was important information, but it was still on the some of the use cases, which again I cannot name the use cases here because otherwise I'll be just saying it publicly. Some of the risks, but we were just shared the name and the payroll information and a little bit more. But these data breaches can create national security, can create, I think it can create economical impact depending on where the one of the project we involved. If data get into the wrong hands at official, it definitely can create economical impact. It can create diplomatic impact, reputation damage, and sometimes risk of safety of some of those individuals as well. So I think the risk can be severe depending on what part of the data get exposed.
So overall, the governments tend not to be classifying data documents anymore. I mean, I remember one time they would stamp it with top secret and confidential and so on, and they would have commercial and confidence. So generally, in government, they don't have that marking anymore with documents, and really it's cryptographic control that's used to limit the access.
So I may differ with you a little bit. May differ with you a little bit. So because um, theoretically speaking, theoretically speaking, we should be marking, the guidance is we should be marking all the document into the right classification. We should be in fact storing the documents into the right classification. So example, a document is classified as secret, should be stored into the secret classification, should never leave the secret classification. If something which is stored at, so when I say, okay, if something is top secret, should be in the top secret minimal. You can although you can store official document into the secret networks, but a network should never be hosting more higher classification than it's supposed to be, it's been accredited for. So I think we do mark, in fact, key, I would say people should be marking the classification correctly. At least it protects that when, if you have to release documents, you release the documents correctly to the lower trust domains. Cryptography definitely have solutions, but that cryptography will play a role when you're releasing that information to the right people. But classification should be specified, in my viewpoint.
And it's great to see that in the UK we now possibly have a framework that allows this data to be shared in a secure way. So, could you give us a quick overview of what the cross-domain hybrid application framework is?
Yeah, yes. So give a bit background. So over a period of when we were building Rosa, we came across so many use cases where data needed to get collected at the lower trust domain or official domain, but when aggregated, should not be kept at official domain. And in also we came across lots of use cases, especially got highlighted during the COVID days, where data is stored on high trust domains, although the single record is official or part of the record is official or low trust, but because the data is stored into the high trust domain, those key individuals had to go to the physical offices, even peak COVID. So many use cases I'm aware of. So this that was a journey of or the birth of the CDHA framework. So CDHA framework, we worked with NCSC from last almost 4 years to build a design pattern, a product, and the libraries, which will allow HMG to build application which will span across security boundaries. It will allow it goes a unique key distribution solution across security boundaries or trust boundaries. It uses high assurance gateways. In our system, we using in our current proposed solution, we are using a bcrypt based FXT gateway, and the reason we using that particular gateway for now, because it does decryption in the hardware. And there are lots of things, because is looking at the threat vectors, that where the threats are and how do you reduce the threat vectors. And because as soon as threats can be from the browser, from the your services, it could be hosting your applications data, and communication layer from orchestrator to the high trust domain. So, this cross domain is a unique crypt solution which will allow HMG to host or build application which will span across security boundaries. We hope NCSC will be publishing the design pattern on their website some point in the future. So we're doing the research project with them. It's funded by NCSC, partially funded by NCSC and partially funded by Acubed.IT. But design pattern is owned by NCSC, and they'll be publishing that design pattern some point on the website.
It's great. And by data aggregation in the sharing, you mean you're taking data from multiple sources? Maybe it's about a person and you're taking bits and pieces of data and then bringing them all together into one master document that might be temporal, or it might be a long-term document. So it's the issue of bringing in all these bits of data into a trusted way and then processing them and then to be able to deliver them to whoever needs to see them to make sure that they have the rights to see them. That what you think of as data aggregation?
Yes, so data aggregation has multiple angles to this. So that's one angle to it, where you creating, that is the first use case where you actually creating that jigsaw puzzles and bringing the complete picture about a person. And the data aggregation could be that, if as example of where you have X number of users and you suddenly lost, not for one person, you've lost the hundred thousands of people in information into the public domain. So I think there are two kind of use cases I see for data aggregation. One is for where a really sensitive information, when plugged together, becomes super sensitive. And the second one is when is a large number of information get lost, which is sensitive information as well.
It's amazing that we've been running the internet for 5 decades or so, and we haven't really developed something like this, especially in government and in critical national infrastructure. So it's really great to see that this has been evolved. Healthcare would obviously be another application area, and just anything with highly sensitive data that needs to be shared with people is important. So, can you explain the shortcomings in traditional data aggregation and how the CDHA framework addresses these?
Correct. So I think so we probably need to understand the current norms right now. So what is the current norm right now? And I'm repeating probably same thing again and again, but I'm just highlighting the same thing. So current norm is right now, if you create or generate data on the low trust domain, then you aggregation and also the whole application state in the low trust domain. If you create and generate the data on the high trust domain, then it means aggregation and the application stays into the high trust domain. So where is the problem statement in this? The problem statement is when the aggregation data stays into the low trust domain, it means the internal case workers, which could be hundreds of internal case workers, also need to work on that data for doing the further processing. It means those hundreds of people can decrypt and access that data. If and the viewpoint is if internal people, if large number of people can decrypt that data, it means hostile state actors can decrypt that data as well. Because and then it means if you look at the picture, it means your whole of the data is exposed to the hostile or can be exposed to the hostile state actor. Again, as I said, the other norm is if you go to the high trust domain, you stay in the high trust domain. It means everybody need to be highly vetted. That systems is only accessible from particular buildings itself. You can't take your official devices on those rooms a lot of time. It means the operational becomes a nightmare. Even though you need to access something which is official, you still go through the pain of highly vetted records. You need to go to the building. You can't take your personal device. You assuming if you're doing an experience check on somebody, then of operational efficiency is seriously poor. And then what happens is in this case, because operational efficiency is bad, people take the risk because of the operational issues that they work at risk at official, and hence the reason of people continue to work at official. In fact, more and more use cases exist where people, because of operational efficiencies, people or deficiencies, people work continue to work on low trust domain and exposing the data which is exist in the low trust domain.
So low trust domain really is a place that really allows a university campus would be a low trust domain because we allow students to come in without checking and so on. But if you went into a government building, then you would get your bags checked. I went to the British Museum recently and they checked all my bags and so on and made sure that I had a ticket and so on. So high trust is typically physical access is highly controlled. Each of the layers of the network are secured, so it would be locked down, typically a zero trust environment where you would need biometrics or something to be able to to get access to the network. Your camera, your phone would be taken off you, any USB sticks and things like that. It's a bit like when you go to a security operations center, you'll find the security operations center is in the middle of the building. It doesn't have any windows. And
Yeah,
then
yeah.
there are regions around the security operations center that have an escalation of security. So I understand that the accesses can come from a low trust level into that high, and how do you control that?
And I think another point I would add. So these high trust domain in the government sector, I also see them as they're not internet connected. They're fully air gapped systems. And when I say fully air gapped system means that they are air gapped. So there is absolutely no internet connectivity whatsoever with these systems as well.
Yeah. Yeah, and we've moved away from sandboxing and that kind of virtual separation, which doesn't really work that well. I mean, just even the feeling that there is a some sort of physical connection there that someone could tamper with. And I think if you go through the FIPS 186 levels, if you go up to the high levels of 4 and 5, then you've got to be air gapping all
Correct.
of your systems
Correct.
together and to jump over them each time. So it makes it difficult to work.
Yes.
And that's obviously one of the barriers, but also obviously highly important. As you say, at the highest level, there's a risk to life, there's a risk to the country against adversarial states and so on. So it's really important that these things happen. So, what's the specific features of CDHA that contributes to enhancing data security and interoperability across these domains?
So one of the key reasons why the CDHA in fact came into the discussion is the advancement of next generation API gateways. So before people need to understand the cross domain, people also need to understand the high assurance gateways. These high and UK is much more advanced than most of the world. fortunately, and we're doing some people at West with some industry partners are doing awesome job in building these gateways. And these gateways exist three different kind of gateways. One is the your one are the one are, oh, one of them are VDI based gateways, which connects to allows you to do browse down or peer networks you can see as a VDIs. Second type of gateways, and they are normally done by BAE and Garrison, both are quite doing a really good job in this. Second kind of gateways are which is for a known structured data to move, and these gateways are way more than just deep shipping. So they basically regenerate the whole document again. And Deep Secure does really good job in doing a known structured data. And then over a period of last when these were matured, another thing came up is, you know what, we solved the non-structured data, we solved the VDIs. Now we need to solve the API so we can actually build applications. And people at West started working on a couple of gateway technologies which allows you to uh, send structured data and do the schema validations and lots of other checks which these gateway does. Um, there are a couple of gateways exist for this, and one of the gateway does not do. In fact, even for structured data, they don't do decryption on the hardware. So what is the risk? So when if they don't do decryption on the hardware, it means you have to, if you're sending a decrypted encrypted data, then you have to do the decryption zone or DMZ, and suddenly that DMZ is in the other side of the other side of the gateway. And what you're doing it is you basically creating a risk profile out there, or a nightmare to manage if you put a diode in the front. So the gateway technology we used is a bcrypt based APXT, which allows you to do decryption in the hardware. Now, assuming now these gateways are built, so that's one thing which allows us to say, you know, now this capability exists. Can we now build an application which can span across security boundaries? We build a cross-domain key management solution. And key management is also quite critical. Why? Because if you can't do the distribution of keys correctly, it means you can't go further anyway. And you sometimes your users could be users could be citizens, and sometimes could be internal task force. Internal task force is still much more easy to share and send them the YubiKey and everything, so you probably can control their devices. But if it's a citizens who does, or your regulators or OES or people not connected to your internal network, then managing their keys are quite complex job, and which makes it project to be go no go in that direction. So we solved that problem. We solved the key distribution across security boundaries, and then we put a crypt solutions on top of how the data works. So at low side, in a simple term, at official domain or low trust domain, data is always encrypted using the keys which is hosted by the user itself in the low trust domain. And data on the high side, when aggregated, it is decrypted. So it means aggregated data is protected using the security features of the higher trust domain, and on the low trust data is encrypted using the ephemeral keys. It's use ephemeral key row level when it's stored into the staging area.
Yeah. And so could CDHA, the CDHA framework be a disruptor and fundamentally change the way that we architect cross-domain applications?
So I this is what I believe, I strongly believe. So this can fundamentally change how we design and architect the applications. Because currently, because of this norm, we work on the low trust or we work on the high trust. What we advocating is, no, you don't need to work on the norm. You don't need to stay on one domain only. It's need to be true interoperability. It's need to be data sharing. Stay on the low side when you aggregating it, but always protected using those keys, and then you bring it to the high side for decrypting and for aggregation itself. So it definitely fundamentally will change how we architect the applications in the future if people continue to use CDHA.
And what's the basic use cases apart from the one that you talked about in governments? What would other use cases be?
So I think I was thinking about I think the use cases, and I'm just being a little bit mindful of not putting those name of those projects in this public domain, and I'm really mindful. So I would say the use cases are wherever a project is collecting a sensitive information, and when aggregated, it can create a risk of reputation, national security, risk to the life, or economical impact, or diplomatic impact. My viewpoint would be all of those use cases should store data or should use CDHA to build a cross-domain applications. So this is for the public sector or HMG or defense. On the other side, wherever they're collecting data on the higher tier, but they need to release a part of the data to the low trust domain. There are also the use cases where data get created on the high side. Let's assume a organization. I know the example which I can discuss here. There is an organization which creates a contract, but that particular contract, for every single contract, if get exposed, it can create some risk to the national security. But if part of the record or part of the contract needs to be signed by third party, which are not on the network, you can share that part of the record to the low trust user. And that is a true example of high to low communication where you're still aggregating on the high side, you're protecting it by the security feature of a high trust domain, but you're releasing a partial information to the low trust. So that is for the HMG where, but then there is a third case, and the third case is private sector also is a we receive ransomware attack a lot of time for the crown jewel. And currently, if you need to protect that crown jewel across an air gap systems, this system can also allows you, the CDHA can also allows you to utilize utilize the air gap systems, these gateway technologies which we're working with Intel, and I'll come to that in a few minutes. Uh, Allows you to build in air gap systems, which and you can protect that information in air gap system, but release it in a controlled manner when it's need to be released.
I mean, there's lots of applications of this, and you would think that HR. I mean, I suppose a lot of the problem with many organizations is they don't differentiate a lot of their data, where HR is probably the highest, most sensitive. If ransomware, if data was exfiltrated from the HR system, then the company would be in big trouble. And that HR data tends to be a SaaS system that's off-site, and they don't actually have control of that. So I think anything where there is that high level in HR systems, healthcare systems, financial data, and so on are highly sensitive. Anywhere where you touch that data, you need to aggregate. I mean, why do you need all the details where you're only wanting to know the average value of the salary of all your employees and so on? And I think a lot of companies don't understand this aggregation of data or the processing of data front end. And especially if we move to AI, there must be much more of this pre-processing of data, and all you see is the result. And then if you need to protect that, you can put the data into a secure enclave.
Correct.
So what's the core benefits of implementing the framework, do you think?
I think the core benefit for implementing the framework, it allows you, so there are two kind of challenges. So I'll first touch base the public sector or the national security. If people work at risk when they work at low side or lower trust, aggregating in the low trust, and people, if they work on the higher trust only, then people work on the operational deficiencies because of the vetting, high level of vetting, access to the building, no access to the official domain. So CDHA gives you best of both worlds. CDHA allows you to architect the applications where you continue to work on the low trust domain. And when aggregation happens on the high trust and release the part of the information from high trust to low trust on the need to know basis. It goes through a lot of export controls and encryption. So when, just for the example, when the high trust data, so let's assume I am a internal case worker and I am working on the one of the one of the use case for I am just being mindful of not using any of the project name. Apologies for this. One of the use case where I need to do experience check on somebody. I need to access bills record from the high side. So I make a request. When the request comes to the low side, it also validates lots of checks that is Amit should have access, is the data is classified as official, is Amit should have access 5 records. It goes through the pipelines of export control. And then it encrypts the data for Amit. So it means only Amit can decrypt the data in the browser session. Nobody else can decrypt the data because it uses part of my key, part of the high side key to create that key or data encryption key, which is I can only generate on the low side itself.
And obviously we're going to enter a transition phase. Just now for key exchange, we use elliptic curve Diffie-Hellman, and for digital signatures, for defining the trust, so I know that I'm connecting to the right API or the right system, I use digital signatures, RSA, ECDSA, EDDSA, and so on. But the problem is that quantum computers will come along sometime, and it's known that there are some threat actors who are already harvesting data that might be cracked when quantum computers come along. So, what things are you putting in with your plans to look towards moving the framework towards a post-quantum robust infrastructure?
So I'm glad you asked that question, sir. What we doing it is at this stage. So only thing which we can say that we using the data is always get encrypted using that AES, which is AES 256 GCM type encryptions. But in order to change the ACDHA and ECDS for signature, ACDH and ECDSA for signature verification and Diffie-Hellman, we are probably going to do or we are now working with Napier University for doing the KTP and also potential a postgraduate student for doing the research understanding of how come these advanced technologies of PQC, attribute-based encryptions, homomorphic encryptions, and also attribute-based encryptions, and also probably the ML and AI-based stuff. I'll come to that in a few minutes. So we will work with the Napier University to understand the tech first, and then start to look at that how do we transit from the current ECDH, ECDSA, and also probably AES in the future to the future PQC crypt solutions. So I was in the Cyber UK this week, and I've spoken to one of the NCSC responsible person for PQC area, and I think the guidelines for UK right now is let's wait for NIST to publish those candidates, which is going to happen very soon, and then you start reacting to it. So I think we're probably going to just wait for the NIST to publish those crypt guidelines as well.
Yeah, that's great. I think it should happen quite soon. So
Yes.
Kyber has been selected
Yes.
for quantum cryptography, and there's some worries about it already.
Yes.
And Dilithium, Falcon, and Sphinx Plus are up for the digital signatures, but it'll take a while to evolve. But obviously, the critical national infrastructure, the finance industry are going to be the key areas that will be developed first, I would think. So apart from post-quantum cryptography, what are the other developments and improvements that you're likely to be making with the framework?
So I think, as I already mentioned, though, PQC is one area. The next top area, which I probably also want to, or we want to explore, is AI or machine learning based export control or release mechanism. Because current release mechanism, which is export control from high to low, uses a rule-based engine to say, you predefine a rule-based engine right now that what should go from high to low, but there's definitely room for improvement out there as to how do you make that uh, machine learning and AI based system. So that's one area. We also want to do attribute-based encryptions. So there are some of the use cases we came across where a part of the information should be decrypted or encrypted using the user's key, which user should have access. So it means that whole document even can travel to the low side, but it should only decrypt the data which a user should have access. So third topic is homomorphic encryptions, which I always confuse homomorphic encryption. So in fact, I was talking to Sammy. I can't remember his second name. He's a CEO for NCSC Canada, and they ran a competition to do the use the homomorphic for checking the signature. And I'm really confused. I'm really confused about homomorphic, to be honest. And hence we want to do more work with Napier University to understand the applications of this, understand the tech for this, and then how do we define the applications for this? Because again, these are the areas. Another area is confidential compute. So we've been talking to Intel right now for looking at how can we use the confidential compute to protect some of the residual risk we have. So we do have a couple of residual risk because you can't solve everything with this tech. So we have a couple of residual risk, and we looking to solve those residual risk using the confidential compute as well.
It's great. Yeah. I mean, obviously, homomorphic encryption is the holy grail because we protect over the air just now, we protect at rest, but do we protect in memory? And that's obviously a difficult area. And we could be encrypting data with the public key of the contracts that processes the homomorphic encryption, or the public key of the citizen, so that only they can actually decrypt the data. So it could be very useful, but overall, if you have this key pair, the public key will encrypt it, and there is only one private key that can actually decrypt it. So you can't cross fertilize homomorphic encryption data. So you can't decrypt with a different public key. So I think in a government situation, that's a perfect example because I, as a citizen, might say, you can use my data for cancer research, but I don't want you to be selling it to Google and so on. So if the key is encrypted with a certain key, then it could be shown that it's only going to be used for that application. And then you can lock it into the process that actually creates it, and then have secure enclaves and so on. So
I think
obviously,
apologies,
yeah.
sorry, sir. Apologies. You go ahead, sir.
No, no, go ahead.
So I exactly what you said is I think we want to learn more these advanced cryptography methods, and to see learning more will allow us to start thinking that how do you use the best application, because joining those two dots together is also one of the things which we are responsible for it. That once we understand the tech well with you, with Napier University, how do we implement into the applications?
That's great. And it's really great that you're investing in research that can bring forward the products and the services and the lead for the future. And it's great to see that small UK companies are doing this thing. So one of your one of the issues that you'll have is obviously you're going to have to deploy this into different companies and different organizations that might have different types of infrastructures. So, what sort of challenges do you think you'll have to be able to shoehorn in this framework into partner agencies?
So, do you mind if I ask you to repeat the question, because I think I did not understood the question clearly, sir.
Yeah. So obviously, companies will have to adapt their existing systems. Say, I have a database that provides a government with some data. So is this going to be an easy integration? Do I just have a little widget that makes it all work, or will I have to change my approaches in setting these things up? I assume it must be to do with a government supplier list, that companies have a minimum standard and will be audited to these things, have to prove that they have air gaps and so on. So, what challenges do you think you'll face in actually getting the data providers up to scratch?
So very, 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 very important point you raised it. In fact, I should have said that in the discussion in the last question, that what other improvements you want to do. And other improvements we want to do is to enable more CDHA usage for existing complex applications. So let's start again. So answering your questions currently, CDHA is currently designed or best used when it's when your architecture is designed for CDHA. So, and the reason I say that, if you build applications which are CDHA aware, so this allows you, and this term secure by design, and I have got a informal agreement or informal statement from people at West that if you use CDHA, you actually secure by design, because what you re-architecturing the whole, or you architecturing the design security first in the head. Otherwise, you would not be talking using CDHA as example. So CDHA currently is designed for greenfield projects where you re-architecture the system, you design it, but can it be used with the existing applications? So we are involved into one of the other national security projects in government, and we recently have used components of CDHA to add extra security postures on the current applications. So you can use a component of the CDHA to secure part of it. But truly, if you say, Amit, I'm gonna go to the stride, and everything on the low side, everything in the low side gonna get compromised. Everything on the low side is gonna get compromised. People will put their own gateways. People will replace the applications with the hostile state actor applications. They will have access to the all over database. They will compromise the machines and everything. If that is the case, a true CDHA still protects the data. But if you use part of the CDHA, it means it only protects what it can protect, the data. So answering your questions in a simple term, CDHA currently is designed or best utilized when you re-architecture the applications, which is CDHA aware application.
I agree. And I think the major problem we have with cybersecurity is that virtually everything is legacy and we're just building on sand. And when we migrated from on-premise to the cloud, we just shoved everything that we had into the cloud. Our protocols aren't really designed to be to work together. Only end-to-end encryption really works. Only encryption of the data at its source is the solution. And we should be looking at overlay networks to hide information like IP addresses and use proxies and so on. So it's great to see that through the NCSE, there might be an uplift in industry as people adopt better things. But obviously, it's difficult in some situations to re-architect. But eventually, if you want to be properly secure, then you really need to be moving. I think the number of ransomware attacks that's happening just now is just going through the roof, and it's quite embarrassing as to the scope of what's happening, especially when it involves citizen data that's sensitive. It could be very costly for a government to have to pay ransoms and litigation cases. So you've got a long track record of history, and you could have a cushy 9 to 5, Monday to Friday existence. What drove you to creating your own company?
So I think it's the so when we were building Rosa, and this company is actually originated because of the Rosa, I would say. So thanks to, I'm quite lucky to be part of that place during the time. So when we saw a lot of people struggling to exploit and build applications which actually can stay on the low side, but then go to the high side, and then everybody was just working norms, and we thought we actually truly have the answer to that question, and hence we went to NCSE. They funded the research since last almost 4 years, and that just triggers. So I really enjoy, and I think, in fact, I will go further. So when I was working, and I'm not sure should I say this in a public domain or not, when I was working as a resource, although I've been quite lucky with the projects, but I still was under the boundaries of what I was told to do. I think the company, creating my own company allows me to drive the innovation better. I think we can make the decisions and drive innovation better. I think that's what I would say. Is I think that's probably one of the reasons I really enjoy. We can come up with or I can come up with the ideas in the night, and next day morning we can actually say, let's get on with it and let's start that piece of work. I think.
It's great. Great. Yeah, it's a bit like working in academia, where you are independent in your research and you're trying to innovate. The only way you can survive, I mean, the reason that Apple are the most worthy company in the world is because they innovated. They continually innovate. So when you're constrained in a company, then you have to create business cases and there's plans and there's committees that need to approve things. So at least you're in control of your own destiny. And we
I
need
know.
more companies like yourself in the UK.
So, and also I go further. So in fact, we are again very lucky that most of the people who works in Acubed IT are also have experience of working with us. So we have a very high trust of people we work with. And it's not only me and one of the resource, let's assume Gaurav and Wesley, they come with an idea. Amit, we got an idea. So the answer is, don't, why you asking me? If you got an idea, don't even ask me because then I'm a blocker. If you got an idea, just get on with it. Just get on. Because more, I truly think innovation is the most important part. Is the most satisfactory and most important part. I think it's just the feeling you get once you actually create what you had. And 9 out of 10, 10 times you may fail as well. So, but that one time is what we need. Is one time is that what we need. So I think we got a great culture in the AQ IT. I think that's what I think as a CEO. People may have a different point of view, but I definitely think we have a great culture.
Yeah, yeah. I mean, failure is part of a business. And Steve Jobs, for example, was kicked out of Apple,
Yeah, I
and
know.
and he came back, and he was a much better person for that. So failure is a core part, but you
Yes.
learn from your failures, and hopefully that can then lead to success. So apart from cybersecurity and your family, what's the things you're most passionate about and why?
So I think I'm quite social animal, and I enjoy playing sports. And some people does find it surprising that I play 5 days a week minimum for 2 hours, and sometimes 6 days a week. I play cricket and badminton in league level, but I just play, and I think that's and playing with the friends and then going out for a quick drink sometime after the games. I think that social part during that time I have no remembrance of that do I even work anywhere, and that 2.5 hours or 3 hours just takes the whole thing out of the system. Proper detoxing every night.
That's great. And what does the next decade of cybersecurity look like? What are the key problems that we need to solve?
So I think so next decade is a quite large time. So in fact, you probably maybe the professor will maybe the best person to answer that question rather than me, because you probably have much wider viewpoint on this one. I So do mind if I request you to answer that question for your viewpoint on this one?
I think the data sharing, the data access, the zero trust, the integration of encryption, and really the trustworthiness of data is obviously a core thing. The integration of people into the internet using biometrics and so on, but finding ways that we don't put barriers in people's way. I mean, again, I go back to Apple are excellent at integrating security without actually creating any barriers for the user. There are many things I think that we need to solve, but I think you're touching on probably the number one thing is that how do we share data between domains? Because we need to share that much more. Uh, hos- Hospitals need to share data. We need to share social care data with hospitals and so on. And there are so many barriers in the way, and we silo data in the public sector. And the idea is to merge the data all together into big data lakes, and that can become really scary. So government really needs to understand how they can start to be able to aggregate data in a way that doesn't breach privacy and increases trust and doesn't open up a can of worms for us in the defense of our nation.
I
So if yeah,
I agree, sir.
yeah. And so if you were to give advice to a technology innovator, uh, what areas do you think they should be targeting on at the current time?
So I think because my answer would be quite influenced by the experience I have because I work in the cybersecurity space. So my advice would be probably influenced by the cybersecurity area itself. So I would say innovators, or I came across quite a few innovators recently during some of the incubator programs. So go deep into the crypt solutions. So actually understand the real need and uniqueness of your solution because a lot of time we go and I am one of those who go into illusion that I am the only one who has the answer. So actually truly validate the opportunity, validate the market size, and then validate the your solution against that market, that are you really the truly the unique part. I think the quantum and AI will create a massive opportunity and also the threat for our cyber world, I think. So both of them, so we have seen AI so far not creating the massive threat to the AI or to the cyber world yet. And I say yet because I think AI will play quite a major role in the future attacks on the systems. We started seeing already some of the examples, but advancement of AI will create quite a big role in the threats and the cyber attacks on the systems. And
Yeah,
quantum will, when the quantum is actually ready, it will be quite a big scare. I think that would be quite scary time. So if we can solve some of those problems, I think those massive opportunities and our responsibility to solve those problems. I think.
yeah, yeah. No, I agree completely. I mean, obviously, advanced persistent threat will now become AI driven. So humans get tired
Yes.
and give up. And
Yes.
but I think with a bot, it doesn't get tired anymore, and it will just keep going. And then you'll have the automated pen testing of a company or a person, and they will be scanning all the time. You won't know the
All the
difference
time.
between
And
humans and
learning and improving,
yeah,
learning and improving.
sharing
And I
notes.
think that
Yeah,
learning and improving is the quite scary part. I think could be quite scary part.
yeah. Because I think Meta have released an open source machine learning model, LLM model, which means that anybody can start to play with it. So it's not exactly like the AI is now behind a firewall. Every single person on the planet can now access these complex, then someone will crack the
Someone,
models. If we don't lock them down with cryptography, then we're in real trouble.
yeah, yeah. And I think crypt will solve because crypt require boot force or require a longer time to decrypt those records. Hence, yes, crypt will play a role. But I think again, quantum, although PQ's quantum is still a little bit far away, but it's far enough only if they're harvesting the data now, then you may not be far away. You may not be too far away. I think is so. I think these two areas, security because of the AI and quantum, the threat solving those problems. I personally think cyber would be quite big, big opportunities in the future. I think.
That's good. And if you could change one thing about your career, what would it be?
So I think it's a difficult question to answer. I was thinking, I must say, because I think I've been quite lucky. I worked on a high profile, high, and quite an influential role into a lot of these projects. So what one thing I would change? I'm super excited about everything what I have worked on so far. So I am not sure, to be honest. I actually not thought about this answer yet. That how what one thing I would change? I think, sir, I've been quite lucky on work on the projects. Yeah, I think and everything has just landed in the right time. So I think I'm quite lucky, sir. I'm quite lucky.
Yeah.
I
Yeah.
think. And
Yeah.
I
That's great.
really thoroughly enjoy all the time, all the projects I worked on. Now, if I look back, I really enjoyed those projects, like really enjoyed those projects.
That's great. And so, what advice would you give cybersecurity networking graduates who are near to graduation about the skills and knowledge that they should be picking up?
So I must say, so because we interviewed some of those people recently, and I interviewed somebody very recently, um, and it's my perception only. So please, whoever listening to this, or if you listen to this, take that as a only 1% perception only. So when I interview those people, I want people to be deep tech people, like actual write me the code. And in fact, I go sometime. So I don't care about the syntaxes, but I do care about how do you solve the problem. So one of the best interview I had. In fact, I'll tell you one of the best interview I had. It was for Microsoft, and the interview lasted for 8 hours. And it was, although it may sound like stupid, but I still remember that interview by heart. And even I remember those conversations. And although the interview was done 24 years ago, and I managed to get the role anyway. And it was as simple as they just asked me to go to the whiteboard and said, create me the linked list. Now sort out this linked list. Now add the record on the linked list. But when you're thinking it, I want to hear that thinking. And so why I'm saying this to you right now. So what I know what they were trying to do. They were trying to find out how do you solve the problems? How do you do problem analysis? How do you approach a problem? So I personally think not only learning about the tech, but also about solving and solving these problems and how do you approach those problems. And I think that's quite important. From my point of view, if I had to hire somebody, I would look for two things. A grit. Do you have that grit? And can you solve the problems? So if I give you a problem, tell me how you solve the problems. I want to understand your way, the path, because I've seen over a period of a lot of time, sir, people go into the complex route, but there is a simple path to solve the problem. A lot of time, simple path to solve the problems.
Agree. Sorry to go back to Steve Jobs again, but Steve Jobs was a great believer in no PowerPoint. Don't come to me with a PowerPoint. And he would stand at a whiteboard and they would talk through the problems, and he would abstract and keep things fairly simple. So I agree with you. It's that methodology, and that's we teach our students ciphers. Ciphers are kind of old things. We use encryption now, but training your mind to solve new puzzles that you've never seen before. And kids are excellent at this. You actually find that children, you don't have to tell them how to solve a pig pen cipher. They see it and you ask them, how did you do that? And they go, I have no idea. There's something buried in their intellect that makes them natural solvers. And sometimes we beat that out of them by teaching them methodology and this is the right way to do things. So you're right. And I think capture the flag exercises and hackathons are the place because you need to speak to other people
Look,
too.
look,
You don't just
look.
sit in isolation. So I think if graduates can get involved with their own communities, uh, our cybersecurity society has a conference tomorrow. And as part of that, they're having a capture the flag exercise. And I think it's a great thing where you can expand your learning beyond the class.
And I think you're right. So hackathon, I absolute great believer in hackathon part. Like so those 3 4 days deep dive, so much fun. We used to do this when long line. So I think I'm not sure they were called hackathon, but there was a different terminologies was used 20 25 years ago. But we used to do this 3 days of hardcore working and on solving a problem. You get out of the room, you solve the problem. So I think I agree with you, sir. And
Yeah,
that collaboration, whiteboard, solve. It doesn't work. That's okay. Let's go to the whiteboard, solve the problems, come back again, write it down. Mr. ABC, that's not working. Can you help me out? So I personally think that communications and collaborations definitely another area to work on.
that's great. And obviously our world is becoming increasingly dominated by these West Coast US companies that are getting bigger bigger and more powerful. Uh, Splunk was bought by Cisco, and they're going to become even more powerful. And we see these large cybersecurity companies, typically US based. So we've got to worry for our own economy because you pay tax in the UK, you help your local community and so on. But some of these large companies just get bigger and bigger and they possibly don't pay tax in our country. So we need to protect our economy, create great jobs and grow our innovation and so on. And it's great to see you working with universities and it's really inspiring that you would want to do that to fund a PhD studentship, to do a knowledge transfer partnership with Innovate UK. You really want to drive your innovation and not just stick with the knowledge that you have. So my question is, can small UK-based cybersecurity companies compete effectively against these large and dominant, largely US industry leaders? And if so, what advice would you give them?
So I think you more or less asking the questions, Amit, how do you solve some of those problems today's date? And we have managed to win against big, in fact, big four. One of those time was one of the big four. We managed to beat them. And I think I would say two parts to this. One, especially in the cybersecurity, especially in the national security space, the key component is the trust. Apart from knowing your technology, uh, we this is my perception only again, has worked so far. That doesn't mean it's a correct perception. Is my advice is that you have to build the trust, because trust plays a major role in working and getting those projects signed. um, Other is actually your innovation need to be truly an innovation, so it takes time, so you have to be patient. So advice to the smaller companies, it takes time. You have to keep going, and sometime you have to keep going. And I think we do the same. So CDHA, I'm trying to advocate CDHA for last almost 2 years, although we were in the mix of building it, and now we are ready to go. But I was started the journey of let's bring the project early stage. It takes time, and against you will go against quite bigger organizations. um, and sometime my advice is, which may not work for everybody, is you may work with the primes sometime to build more relationship, build more trust, and do your first project or first few projects. So you sometime work with the prime, and we do this all the time. We work with the primes, and we work, but it's a journey. It's a marathon. It takes time. I believe it takes time, but if you truly believe, if your product solves the problems, it you just have to stay. Just have to stay.
And yeah, small and agile is better than big and
Yes. Oh
verbose.
yes.
And
Oh yes. Oh yes.
when we spun out our company Symphonic, others were saying that IBM and Microsoft do these things, and we say that they don't. So that innovation is key, and moving quickly whenever you see that opportunity is so important. And obviously, it's good to see the NCSE is supporting cybersecurity SMEs, and they do it in the US. In the US, DARPA, the DARPANet supported companies to grow. Cisco and all these companies grew from that research and that innovation that happened around that time. So I think it's important for the government to really support its own companies and not give that away necessarily. And obviously, if it's homeland defense, then you need to make sure that you have companies close to you physically to make sure that things are working well. So
So I think you touched the point which I should have also mentioned it. So I agree with you, sir, that these programs like DARPA, NCC Startup, DC Runway, and few other programs are quite important for not only for increasing the innovation, but also to give the visibility of the smaller organizations to the whole world. And I think that visibility is also equally important as well.
Okay, well, thanks very much. Sorry for taking up so much of your valuable time today, and all the best for the future, and well done for really innovating in such an important area. I think data sharing and highly trusted data sharing hasn't been solved, and hopefully you'll be able to uh, show companies the way that they should be going, and hopefully build a better and more trusted digital world. Okay, thank you.
Thank you very much, sir. Thank you.